Welcome to the DIY Honda Garage channel. The DTC P0453 indicates a high voltage reading in the FTP, fuel tank pressure sensor circuit. This fault is critical as it can lead to incorrect readings of fuel vapor emissions from the evaporative emission control system, thus potentially causing excessive emissions or a malfunction of the vehicle's performance. The FTP sensor is located near the fuel tank, typically on the pressure line connected to the fuel tank, and it plays a crucial role in monitoring vapor levels inside the tank. This measurement is essential for optimizing the engine's performance and reducing harmful emissions into the atmosphere. Diagnosing DTC P0453 involves systematically checking various components and wiring associated with the FTP sensor to ensure everything is functioning correctly. Proper troubleshooting steps are vital to isolate the issue, ascertain the integrity of both the sensor and the wiring, and implement the necessary repairs effectively. The DTC P0453 describes a problem specifically with the FTP sensor circuit. This sensor, located close to the vehicle's fuel tank, is responsible for detecting the pressure of fuel vapors within the tank. By measuring the amount of vapor, the sensor aids in the effective management of the evap system to prevent fuel vapors from escaping into the environment. When the FTP sensor detects a voltage reading that exceeds normal limits, it triggers this Diagnostic Trouble Code. This situation often arises due to a faulty sensor, poor connections, or issues in the wiring harness leading to the sensor or the powertrain control module, PCM. Understanding the sensor's role is critical. It has an essential impact on the vehicle's emissions control strategy, thus maintaining both performance and environmental compliance. The possible causes for DTC P0453 can be categorized into three main issues. First, a faulty FTP sensor is the most common culprit. Sensors can fail mechanically or electrically over time and lead to erroneous readings. Second, wiring issues could also cause the circuit to register high voltage. Damaged, frayed, or corroded wiring connections may contribute to the problem. Lastly, poor connections can impact the circuit's reliability. This includes loose or dirty terminals that disrupt the electrical flow. Each of these causes directly relates to the sensor's ability to accurately detect fuel vapor pressure. During diagnostics, each potential cause must be systematically evaluated to pinpoint the source of the fault effectively. Symptoms associated with DTC P0453 include the activation of the check engine light (CEL) on the dashboard. This warning alerts the driver to a possible malfunction within the vehicle's systems. Additionally, drivers may also experience poor fuel efficiency as the engine struggles to operate efficiently due to incorrect readings from the FTP sensor. Another potential symptom is increased exhaust emissions. Faulty readings can prevent the proper management of fuel vapors, subsequently leading to non-compliance with emission standards. Consistent monitoring of these symptoms can guide maintenance and troubleshooting efforts, helping to prevent further issues down the road. To begin troubleshooting DTC P0453, first switch the vehicle to the on mode without starting the engine. This allows for the necessary diagnostics to be performed using the HDS Honda Diagnostics system. To proceed, the Diagnostic Trouble Code should be cleared, which can be done efficiently with the HDS tool. Next, it is crucial to insert the emergency fuel funnel into the fuel filler neck. This is stored in the trunk toolbox and is essential for allowing pressure to be monitored accurately. Once these steps are completed, it's time to check specific parameters from the HDS, particularly focusing on the FTP sensor's voltage readings to determine if they align with expected thresholds. In the second troubleshooting step, the emergency fuel funnel must be removed from the fuel filler neck. Subsequently, start the engine and hold the RPM at 3000 until the radiator fan activates. Then allow it to return to idle. This step helps in elevating conditions that can simulate the fault for accurate diagnostics. The next action involves using the HDS to monitor the OBD, onboard diagnostics, status for DTC P0453. If the HDS indicates failed, this confirms that the issue exists and you should proceed to step 3. However, if it shows passed or indicates an intermittent failure, then it might point to a temporary condition that requires checking for poor connections or loose terminals that might have allowed for normal operation. For the third troubleshooting step, begin by turning the vehicle to the off mode. Disconnect the FTP sensor's 3P connector to isolate the sensor from the system. After disconnecting, connect terminals A and B using a jumper wire to create a closed circuit that will bypass the sensor. Reapply power by turning the vehicle to the on mode, and then use the HDS to check the voltage at the FTP sensor. You need to evaluate whether the voltage exceeds 4.7 volts as specified by the diagnostic criteria. If it does, this indicates that the problem lies within the FTP sensor itself, necessitating its replacement. If the voltage is lower, further investigations into wiring or other components are warranted. In the fourth troubleshooting step, again switch the vehicle to the off mode. Following this, remove the jumper wire used in the previous step to allow for normal operation of the circuit. Reapply power to the system by turning the vehicle to the on mode. It's crucial to measure the voltage between specific test points 1 and 2, identified in the diagnostics to ascertain the operational integrity of the FTP sensor circuit. The desired measurement under these conditions should be approximately 5.0 volts. If this voltage is observed, the circuit is functioning correctly, leading to the next troubleshooting step. If not, the investigation must continue into other components for further issues affecting the FTP sensor circuit. For step 5, turn the vehicle to the off mode before beginning work. Use the HDS to jump the SCS short circuit line and wait for more than a minute to ensure the system is reset. Disconnect the PCM, Powertrain Control Module, connector A to ensure there is no interference while testing the circuitry. Connect terminals A and B of the FTP sensor to body ground with a jumper wire, which is crucial for checking the line's integrity. Test for continuity between the designated test points post-connection. If continuity exists, this indicates that the P-tank wiring, fuel tank pressure wire, is intact, allowing for further assessment of the PCM. If continuity is not present, this signals an open circuit that must be repaired, restoring the integrity of the P-tank wire. Step 6 mirrors the previous step, but here we focus on the SG6 wiring. Again, begin by turning the vehicle to the off mode and use the HDS to jump the SCS line, waiting more than a minute. This resets the system, facilitating more accurate diagnostics. Disconnect the PCM connector E before proceeding to connect the jumper again to the FTP sensor as per diagnostic instructions. Check for continuity between the specified test points. Achieving continuity confirms the SG6 wire's operational status. Should you find continuity, further checks with authorized service information are warranted. A replacement of the PCM should follow if the DTC persists after substitution. However, if continuity is lacking, repair work is necessary on the SG6 wire to rectify the open circuit issue. Upon completing the repairs and replacements for the DTC P0453 issue, It is essential to reconnect all previously disconnected connectors to restore the vehicle to its operational state. Once everything is in place, the next critical step is to conduct a final check using the HDS. This reevaluation will ensure that the fault code has been successfully resolved and that no new codes have emerged during the repair process. Confirming that the vehicle behaves normally with no significant warning lights showing on the dashboard is crucial for guaranteeing proper functioning. It is at this stage that any lingering problems must be addressed to affirm the repair success fully, allowing the vehicle to perform optimally and meet emission standards. Preventive maintenance is vital to ensure the longevity and reliability of the fuel system, including the FTP sensor. Regular inspections of all connectors and wiring related to the FTP sensor help to identify any corrosion or wear that could lead to deterioration over time. Keeping terminals clean and free of debris also supports optimal electrical conductivity, reducing the chances of high voltage readings that can trigger DTCs. Maintaining a close eye on the vehicle's overall performance, specifically looking for variations in fuel efficiency or any warning lights, serves as an early warning system for potential issues. Staying proactive in these areas will mitigate the risk of future malfunctions and contribute to a smoother driving experience. In summary, understanding the role of the FTP sensor and its impact on vehicle performance is essential for effective troubleshooting of DTC P0453. By conducting thorough diagnostics, technicians can systematically identify and fix issues, restoring proper functionality to the sensor circuit. Attention to detail during each diagnostic step is crucial for accurately determining the source of the problem and implementing the right solutions. Moreover, prioritizing preventive maintenance plays a key role in ensuring the longevity of vehicle components, thus avoiding unexpected repairs in the future. Following these guidelines will contribute to improved vehicle performance and adherence to environmental standards, ultimately leading to a more efficient and compliant vehicle. Please like and subscribe to the channel. See you next time.